Okay, hi everyone. Today we're going to do adding fractions and subtracting fractions. So how do we add and minus fractions? Now, first of all, adding fractions is quite easy. If the fraction have the same denominator, so fractions can be simplified easily. If using addition, if they are like fractions, that is, if they have the same denominator, and this means they can be divided into the same number of pieces. So an example of that is, we have, for example, a rectangle, and this rectangle is divided into 4 equal rectangles. And then I have another same rectangle. It is also divided into 4 equal rectangles. Also, the size of these two rectangles looks different, but let's just assume they are the same rectangles. And then if we shaded this part, just the first part, and then I can say, what is the fraction of the shaded part to the whole part? And that will be 1 out of 4. And if I just shaded 2 parts here, then you will say that's 2 out of 4. Then if we want to plus them together, well, that's pretty easy. Graphically, you just plus another shaded region, and you're going to have 3 parts that's shaded. 1, 2, and 3. And then that means, it is equal to 3 over 4. All right, so of course the way to do it is basically if you have the same denominator, you just add the numerators together. All right, so that's the same idea. That's the idea. If we have fractions with the same denominator, and if we want to plus the 2 fractions together, then it's really simple. We'll just add them together. Just simply add the numerators and keep the denominators. All right, this is something that it's really important. You only add numerators, as you can see here. All right, please do not add the denominator. You're going to keep the denominator the same. All right, so this allows you to find the total number of divided pieces. Okay, so I'm just going to write this one down. If 2 or more fractions have the same denominator, okay, then what we have to do is we simply add the numerators together. So we simply add the numerator, and what we need to do is make sure that you keep, okay, this is very important, we're going to keep the denominator, not change. All right, so this is really easy. I'll just give you some simple examples. If we have 2 over 5 plus 1 over 5, and that becomes 3 over 5. Very simple. And if you have a number that's 4 over 7, slightly larger, and you have like 6 over 7, and you will get an improper fraction, which is 10 over 7. All right. Sometimes you do get questions like 2 over 12 plus 4 over 12, and that gives you 6 over 12. And sometimes when you get to this point, what you need to do is obviously simplify your answer. 6 over 12 is actually equals to half. All right, so your final answer is always going to be the simplest answer. All right, so this is what happened if if it's the same denominator. Now, what happened if it's different denominator? All right, because most of the time you're not going to get questions where the denominators are equal to each other. So what do we do if the denominators are different? Oops. Okay, so we have different denominators, and what do we do? Okay, so if the denominators are different, then what we need to do is we need to make sure the denominators are the same. Okay, so this is what we need to do. So if they're different, well, we need to make them the same. We can't deal with fractions, addition, and subtractions if the denominators are different. Okay, so we have to do it if the denominators are the same. So therefore, what you need to do is we need to use the knowledge of equivalent fractions to convert them into the fraction with the same lowest common denominator. All right, so what we're going to do is we're going to convert, all right, fractions, all right, two fractions with the same lowest common denominator. Oops. Okay, and we call that LCD, lowest common denominator. All right, so I'd like to show you how to do it. If the denominators are different, and how do we plus the fractions together? All right, so let's have a look at a question. So if we have like 3 over 4 and 1 plus 5 over 6. So what you need to do here is the first thing you need to think about what is the lowest common denominator. So we have a both denominator, one is equal to 4, the other one is equal to 6. All right, what is the common multiples, right? That's what you need to think about. And what is the lowest common multiples? So if you think about 4 and 6, all right, number 4 and number 6. If I try to write down all the multiples, you will have 4 and 8 and 12 and 16 and it goes on. For 6, we'll have 6, 12, 18, and obviously we'll go, 24 and continue. All right, for 4, what we can do is that becomes 20 and 24 and continue as well. All right, so if we look at which one is the common multiples, as you can see, 12 and 12 are the common multiples. 24 and 24 is also the common multiples. And obviously we can have more common multiples at the end because we have an infinite number of multiples. But which multiples are we going to use? Are we going to use 12 or are we going to use 24? Is there any difference? Yes, there are difference, all right, they're different. You have to use, well, no, not really. You don't have to use the lowest common multiples, but it is ideal that you're using the lowest common multiples, right, to form that lowest common denominator. The reason for that is if you choose to use 24, because some people, they just say, oh, that's easy. We'll just simply times 4 and 6 together, and 4 times 6 is equal to 24, and then let's just make everything into 24, and that becomes the common denominator. Can I do that? Well, the answer to that is yes, you can, but towards the end, you might need to, or highly likely, you are going to simplify your fraction. It's just going to be additional work that you need to do. And I'm not saying that if you choose the lowest common denominator that you don't have to simplify your answer towards the end, but it just makes your answer slightly easier, okay, to simplify comparing to if you're using a large number. Imagine if the denominator is not equal to 4 and 6. Imagine if the denominator is equal to 12 and 18, for example. Are you going to find the common multiples by simply times these two numbers together to get a huge number at the end? Well, the answer to that is no. You have to find the lowest common multiples. So it makes easier, all right, to do the calculation there. All right, so that's an idea. If you do want to just times the numbers, I have no problem with that as long as you can simplify your fractions properly. That's all, okay? All right, now for this question, we have already know that the denominator has to be 12, okay, because that's the lowest common multiples. Now, what do we do? All right, we need to change that into the, equivalent fractions. From the previous lesson, you probably already know how to change it. All right, I'm going to multiply 3 and 3 here, so that gives us 9 on the top. And then I need to times by 2 and 2 to get to 12. So therefore your numerator becomes 10 for the second fraction. Alright, so after you finish this, now what you can do is simply add the numerators together and you get 19 over 12. Do we need to simplify the answer to a mixed numeral? Well, I guess at this stage, yes, you need to. But eventually later on, you don't have to worry about it. I actually prefer the improper fraction than a mixed numeral. Okay, all right. So that's how we do it with different denominators, okay? I'd like to do another one. All right, and this time I'm just going to do a question with 3 different numbers. So 2/3 plus 1 over 5 plus 2 over, let's just make this one a bit hard for everyone to do. Okay, 2 over 6. So how do we add them together? Well, we have to find the lowest common, multiples of the denominator. So we've got 3, we've got 5, and we've got 6. All right, so if we just do a quick calculation, that would be 3, 6, 9, and 12. Probably keep going like a bit over. That's going to be 15, and 18, and 21, and goes on, right? For 5, you will see that's going to be 5, and 10, and 15, and 20, 25, 30, and goes on. For 6 will be 6, 12, 18, 24, 30. All right, now which one is the common multiples and which one is the lowest common multiples? So pretty hard to decide here. But it does look like, you've got 30 and 30, right? They are common. How do we get to 30 here? Well, eventually that 30 times, 3 times by 10 is equal to 30. So we are going to get a 30 there. So that's look like 30 is going to be the lowest common multiples. All right, because apart from 30, I can't think about any other numbers that's going to be less than 30, and it's still a common multiples here. All right, so that means we have to change all the denominators to 30. All right, so we're going to times by 10 here. We're going to times by 6 here. And we're going to times by 5 there. So that gives you 20, 6, and 10. So once you get to that, well, you can simply add the numerators together. So it becomes 36 over 30. Once you finish that, well, please, we haven't finished the question, we can simplify. All right, so that becomes 12 over 10 if you divide both the top and the bottom by 3. But I don't think it's enough. All right, you can actually divide it by 2 again. All right, so that gives you 6 over 5. But obviously, some people can just tell me, hey, what about we just divide everything by, 6? Can I do that? Well, of course, because that's the highest common factor. You can divide by 6. Okay, so that's how you do it, making the same denominator. All right, now, I would like to do one with the mixed numerals. How do we do mixed numerals addition? And then we can talk about what do we do with the, subtraction, because subtraction, to be honest, is they're pretty easy. They're just different to the opposite to addition. Okay, so how do we add mixed numerals? All right, what will be the steps that we need to follow? Okay, to adding the mixed numeral questions. All right, so let's just make this one adding mixed numerals. All right, adding mixed numerals. I'm just going to use one examples. All right, so for example, this question here, all right, as you can see, this question will have the same denominator for the fraction. So the way to do that is pretty easy to do, okay? There are two different ways you can do it. The first method, what I'd like to do is you simply plus the number, all right, in the front, and plus the fractions. You plus the number, you plus the fractions, right, separately. So that gives you 3 plus 4. All right, I'm just going to group it. And then 2 over 3 plus 2 over 3 and group it. So that becomes 7, and then you've got 4 over 3. Now, it is going to be a bit weird to have a 7 and then 4 over 3. So what you need to do is to change that number into a mixed numeral again, okay? So you can actually add the number in the front. All right, so that gives you 7 plus 1 and 1/3. All right, which now 1 and 7 combined together gives you 8. Oh, all right, 8 and 1/3. So that's the first method you can do this question here. The second method with this question is you change the mixed numeral back into the improper fraction. So you convert into improper fraction. All right, so convert to improper fraction before you add the fractions together. I don't know, somehow I feel like I will do this method, especially with subtractions, I will use this method here. So I actually be, very confident with converting that into improper fraction. So I feel like it's just easier for me to plus or minus fractions. So now it becomes 11 over 3 plus 14 over 3, which is 25 over 3. And that is, 8 and 1/3. Okay, all right. So this time is then plussing the mixed numerals with same denominator. I'd like to do a question where the denominators are different. So it will be 2 and 3 over 5 plus 3 and 1 over 4. Something like this, okay? All right, with this question, again, same, method apply. It's up to you. It's really up to you. You can use the method 1, which means you just plus 2 and 3 together. And then you plus 3 over 5 and 1 over 4 together. All right? sorry. So that becomes 5. And then for the second fractions, you have to make the same denominator, which is 20. And that's the lowest common multiples. So that becomes 12, and here's 5. Because you multiply by 4 and 5. Okay, all right. So then you plus the two fractions together becomes 17 over 20. So your final answer will be 5 and 17 over 20. That's how you do it. If you don't like this method, which I don't really prefer this method here, I prefer to change the fraction into mixed numerals. But again, it's up to you. So I prefer to change that into 13 over 5 plus that it will be 4. And then that will be 13 again. Oh, they're both equal to 13. Great. All right, and then you find the lowest common multiples, which in this case is at 20 again. All right, so you times by 4, times by 4, times by 5, and times by 5 there. All right, so you're going to do the calculation. That will be 52 and 65. All right, here I get this because it is going to be a larger number, okay? So it becomes 117 over 20, which it is equal to 5 and 7 over 20. Okay, so this is addition. All right, now with subtraction, let me tell you, it's exactly the same, all right? There is no difference, all right? You just have to be careful with subtraction because sometimes with, plus, minus mixed numerals with subtraction, you do need to borrow a number from the number in the front to minus it, all right? So in that case, with subtraction question, I actually prefer everyone using the second method where you convert that into improper fraction and you subtract. Otherwise, you need to think about, borrowing numbers from another, number, which is going to be a very, really annoying. I am just going to try one question and to show you why. Okay. I feel like it's going to be a bit crazy. Okay. All right. So let's do subtracting and let's just do one question. 5 and 2/3 minus 3 and 1/4. All right, so with this question here, the way I do it, I really like to do the question by using the second method. All right, so simply just change everything into the improper fraction. So it's much easier, all right, for us to, That'll be 4 and that's 13. Okay, all right, so make the same denominator. That'll be 12. That'll be 12. And then you multiply here by 4. You multiply by 3 there. So you get 68 and you get 39. So that gives you 29 over 12, which is 2 and 5 over 12. All right, so you got the answers. All right, now, if you don't want to use this method, all right, you can use the first method where you just borrow a whole number and then you subtract the whole numbers from each other and you subtract the fraction from each other. But you just have to be very careful. Sometimes the fraction, when you subtract the fraction like these two, I think it's all right. But with some other questions where you probably is going to get a negative number and it's just going to make the entire process really, really ugly, all right, because you're going to borrow a number from the previous whole number there. All right, I don't recommend, all right, so I actually prefer everyone just using the second method, converting to improper fraction and do the calculation. But to be honest, all right, eventually, by the time you reach year 8, you're allowed to use a calculator, so you are actually using calculators to do the calculation for the fraction addition and subtraction. But by the time you reach year 9, when you start to do the algebra fraction, and this is the time you need to use the skill. So the calculator is not going to help you forever. You still need to know the skills, how to add and subtract fractions. Okay, I hope you guys are enjoying the lesson. Thank you.